Very good morning, students. For this lecturing video session, I am going to take the next chapter of the fourth unit, that is dynamics of particles, right? So here it is, projectile motion. Right. What do you mean by projectile, by the way? When a particle is thrown or projected, when a particle is thrown or projected at an angle with an initial velocity which moves under the effect of gravity and traces a path and traces a parabolic path, okay, a parabola on a vertical plane placed to its path. It is called projectile, right? So it is an example. Projectile is an example of the curvilinear motion. The path traced by the particle in air is known as trajectory. So which is nothing but, so this is the x-axis, this is the y-axis. Assume this is x-axis, y-axis. This is the path is generated, and this is the initial velocity u, and this is the inclination alpha. This is called trajectory. So the path traced by the particle in air is known as trajectory of the particle, where the particle is called projectile. This path traced by the particle is in parabolic distance. So and the distance from that is the displacement is can be denoted as r. So projectile is freely projected particle which moves under the combined effect of vertical and horizontal motion. Okay. So see, as far as the example of the projectile motion is concerned, example is the bullet fire from the gun. Examples are bullet fired from a gun. Then the second one is throwing a cricket ball. Throwing a ball. Cricket ball from one player to another. The third example, a stone thrown horizontally from top of the tower. A stone thrown horizontally from the top of a tower. So a couple of assumptions should be made when you just do the analysis of projectile. Those are the acceleration due to gravity is constant throughout the range, and the air resistance is negligible. Okay. So let me just redraw this diagram in a detailed manner. So this is the trajectory or the projectile. So this is x-axis, this is y-axis. The initial is as O. Let me just take the displacement as r. Okay, and the last point is A, and the maximum distance, let me consider this as B and this point as C. This is the maximum height of the projectile, and this is the alpha, this is the angle, okay, and this is the initial velocity as u, and this is the trajectory. So if you consider the initial velocity in two components, that is horizontal component and vertical component, so this can be denoted as u cos alpha and the vertical component as u sin alpha. Okay. So the terms related to projectile motion are, first one is angle of projection, which is nothing but the alpha. So alpha is the angle with the horizontal, at which the projectile is projected is called the angle of projection. It is denoted by alpha. Let me just repeat. The angle with the horizontal at which the projectile is projected is called the angle of projection. Right. Second one, the velocity of projection. Velocity of projection, which can be denoted as small u. The velocity with which a projectile is projected into space is called the velocity of the projection, and it is denoted by u. The velocity with which the projectile is projected into space is called the velocity of projection. Okay. Third one, time of flight. And it can be denoted as t. So it is the total time taken by a projectile for which the projectile remains in space. Okay. So it is the total time taken from the projectile with which the projectile remains in space. Okay. And it is denoted by t. The fourth term, horizontal range or the displacement. Horizontal range. The horizontal distance between the point of projection and the point where the projectile strikes the ground is called horizontal range. That is, the horizontal distance from the point of projection and the point where the projectile strikes the ground is called horizontal range, and it is denoted by r. Next term is maximum height. Which can be denoted by h max. So this is the h max, right? So it is the maximum vertical distance of the projectile from the point of projection. Okay. It is the maximum height, vertical distance of projectile from the point of projection, and it is denoted by h max. So let me just give some formula to solve the problem, right? So let me just give the formulas first. So the time of flight, which can be denoted by t, isn't it? So either you can just mention as small t or capital T. T is equal to 2 into u sin alpha by g. G is nothing but the acceleration due to gravity. Okay. Next, the maximum height formula. Maximum height attained by the projectile so which can be mentioned as h max. Right. So h max is equal to u square sin square alpha by 2g. Just memorize these formulas. Okay. Next, horizontal range. horizontal range of the projectile R. So R is equal to u square by g into sine 2 alpha. Okay. Fine. So the maximum horizontal range, that is R max, when you will obtain the maximum horizontal thing, when the alpha is equal to 45 degree, right? The maximum is obtained when alpha equal to 45 degree. When it is so, you just apply this 45 here, so sine 90 is 1, so therefore R max equal to u square by g. So these are the formulas which you have to just memorize here, right? So the time of flight, then the maximum height attained by the projectile, then horizontal range of projectile, and the maximum horizontal range, this you will have to memorize it. So here the assumptions, as I told you, the assumptions made for the analysis of projectile motion are: first one, the effect created by the air resistance is negligible, isn't it? So effect created by air resistance is negligible. Second one, the acceleration due to gravity. Acceleration due to gravity, that is denoted by g, is constant, is same over the range of the motion, right? Or the range of motion, and is directed downwards. Okay. I hope you have all understood the concept of the projectile motion and the formulas. So you just memorize this formula, which will be useful for you to solve the problems from projectile motion. Thank you.